It was a time of great hope, a time of boundless curiosity. Back in 1977, we looked up at the night sky and saw not just points of light, but destinations. We imagined worlds beyond our own. We dreamed of reaching out, of touching the cosmos. So we built a messenger, a small determined machine named Voyager 2. It was our promise to the universe, a promise that we were here, that we were listening. Voyager 2 was not alone. Its twin, Voyager 1, launched shortly after. Together they were tasked with an unprecedented journey, a grand tour of the outer planets, Jupiter, Saturn, Uranus, and Neptune. On board it carried a golden record, a time capsule. It contained sounds and images of Earth, the cry of a newborn baby, the music of Bach and Chuck Berry, greetings in 55 languages. And so, on a hot summer day, August 20th, 1977, a Titan rocket roared to life. It pushed Voyager 2 away from the safety of home, away from everything we had ever known. We watched it climb higher and higher, a tiny speck against the vast blue sky, until it disappeared from sight. It was on its way, a lonely traveler on an endless road. The journey was long, and it was lonely. For years, Voyager 2 sailed through the blackness between worlds. Its first major stop, Jupiter, the king of planets. As it drew closer, it sent back images that stunned the world. We saw a world of violent, swirling storms, a great red spot, a hurricane larger than our entire Earth, raging for centuries. We saw thin, faint rings we never knew existed, and we discovered active volcanoes on its moon, Io, spewing sulfur into space. It was a dynamic, chaotic system, more alive than we ever imagined. After its dramatic encounter with Jupiter, Voyager 2 used the giant planet's gravity to slingshot itself toward its next target, Saturn, the jewel of the solar system. Its magnificent rings, once thought to be simple, solid bands, were revealed to be a breathtakingly complex system. Voyager 2 flew past its moons, revealing icy worlds like Enceladus, which hinted at a liquid ocean beneath its frozen crust. The journey pressed onward, into territory no spacecraft had ever visited before. Uranus, a pale blue orb, tipped on its side as if knocked over by a cosmic giant. Finally, nearly 12 years after it left Earth, Voyager 2 reached its last planned stop, the deep blue, wind-swept world of Neptune. Here, it found the fastest winds in the solar system, screaming at over 1,000 miles per hour. Having left the planets behind, Voyager 2 continued its silent voyage. It was now heading toward a frontier we had only ever theorized about, the boundary where the sun's influence ends and interstellar space begins. For years it drifted. Its instruments, still faithfully recording, began to pick up strange new signals, not from aliens, not from another civilization, but from space itself. The constant stream of charged particles from our sun, known as the solar wind, was beginning to slow down. It was as if Voyager 2 was wading into a thick, invisible cosmic fog. The whispers were faint at first, but growing stronger. As it pushed further, the data became even more peculiar. The spacecraft's magnetometers detected a magnetic field that was behaving in ways our models could not explain. It was becoming compressed, distorted. Imagine a bubble being squeezed from the outside. That bubble was our solar system, and something was pushing on it. The particles from deep space, the cosmic rays, were growing in intensity. They were bombarding Voyager 2 with more and more energy. It was as if it had punched through a protective shield and was now exposed to the raw, untamed environment of the galaxy. The most unnerving discovery came from its plasma wave instrument. This device listens to the vibrations of charged particles in space. For decades it had measured the relatively sparse plasma within our solar system. But now, it was picking up something new, a distinct rising tone. The density of the plasma around the spacecraft was increasing dramatically. It was much thicker, much denser than anything it had passed through before. It was like moving from the quiet air of the countryside into the deafening roar of a crowded city. The moment finally came in late 2018. Decades after its launch, billions of miles from home, Voyager 2 crossed the threshold. It had officially entered interstellar space. It was now the second human-made object after its twin to do so. It was swimming in the medium between the stars. The data it sent back was revolutionary. It confirmed that the plasma, the very substance of the galaxy, was far denser and colder than what was inside our solar bubble. It was like stepping out of a warm house into a cold, dense fog. The spacecraft had survived the crossing. It was now an interstellar traveler in the truest sense. But the story did not end there. It became stranger. For months the data streamed back as expected. Voyager 2 was a tiny mote of dust in an immense ancient void. It measured the cosmic rays, the magnetic fields, the particle densities of this new unexplored territory. Then, something happened that no one at NASA could explain. It was an event so subtle, yet so profound, it sent shockwaves through the scientific community. The telemetry from the spacecraft began to shift. It was not a malfunction. The craft was healthy. The change was in its trajectory, its velocity and direction. According to our calculations, Voyager 2 should have continued on its path, moving ever outward, away from the sun, forever. But the data showed something else. Something impossible. It was beginning to slow down. The deceleration was tiny, almost imperceptible. But it was there. And it was steady. Something was acting upon the spacecraft, some force that our physics could not account for. The anomaly grew more pronounced. The faint deceleration was accompanied by a minuscule yet undeniable change in its trajectory. It was as if Voyager 2 was trying to make a turn. A long, slow, impossibly wide arc, but a turn nonetheless. The direction of this turn was the most shocking part of all. It was not veering off into some random direction in the galaxy. The data, when plotted over months and then years, showed the spacecraft was slowly, painstakingly, beginning to curve back in the general direction from which it came, back toward our solar system. This was not supposed to happen. The laws of motion are clear. An object in motion stays in motion unless acted upon by a force. What force could possibly be strong enough, yet subtle enough, to alter the path of a spacecraft billions of miles away? The team at NASA ran every simulation they could think of. They checked for software glitches, for instrument errors, for some kind of propellant leak, however small. Every test came back negative. The spacecraft was performing perfectly. The data was real. Voyager 2 was, against all odds and all known physics, turning around. The implications were staggering. It was as if the spacecraft had hit a wall not of energy or particles but of space-time itself, as if the fabric of the universe was curved in a way we had never imagined. Some theorists proposed radical new ideas. Was our solar system encased in something more than just a magnetic bubble? Was there a larger structure, a sort of cosmic shell, that prevented objects from truly escaping? The idea that something was out there guarding the border of our solar system was no longer just science fiction. To understand what might be happening to Voyager 2, we must look to the most mysterious and distant region of our own solar system. A place we have never seen, the Oort cloud. It is a theoretical, immense sphere of icy bodies that is thought to surround the sun at a vast distance. It is the birthplace of long-period comets. It is the final, true frontier of our solar system. A dark, cold realm, stretching almost a light-year into space. It is here in this great dark sphere that the source of Voyager 2's strange behavior might lie hidden. What if the Oort cloud is not just a scattered collection of icy comets? What if it is something more? The data from Voyager 2 suggests that as it entered this region, it encountered a force that began to slow it down and turn it back. This force could be gravitational, but for gravity to be the cause, there would have to be an object of immense mass hiding in the darkness. A planet far larger than Jupiter, or perhaps even a small, dim star, a failed companion to our own sun, a nemesis star, as some have called it. It could be the first probe to feel the gravitational pull of this hidden giant. A cosmic gatekeeper patrolling the outer darkness, its gravity shaping the very edge of our solar system. But there is another, even more unsettling possibility. What if the force is not gravity? What if it is something we don't have a name for? The data from Voyager 2 showed a sharp increase in plasma density and a strange magnetic field. Perhaps the Oort cloud is not just a collection of objects, but a region where the laws of physics themselves are different. A transitional zone where our solar system interfaces with the galaxy in a way we do not yet comprehend. Voyager 2, our brave little messenger, may have stumbled upon a secret that challenges our most fundamental understanding of the universe. The journey of Voyager 2 has always been a reflection of our own human journey. We are a species born of curiosity. We have an innate desire to see what is over the next hill, across the next ocean, or on the next world. Voyager 2 is the physical embodiment of that spirit. But now the story has taken a darker turn. It has become a story about limits, about boundaries, and about the unsettling possibility that we may be enclosed in ways we never imagined. The fears that have haunted humanity for millennia, fears of the dark, of the unknown, of monsters lurking just beyond the firelight, are now being mirrored in the data from deep space. What if the universe is not an open road but a walled garden? What if there are forces or entities that keep us contained? These are questions that touch upon our deepest anxieties about our place in the cosmos. The saga of Voyager 2 is far from over. Even as it slowly curves through the darkness, it continues to send us its precious data. It is a lifeline to a place we cannot yet reach ourselves. This mission, and the mysteries it has uncovered, will undoubtedly shape the future of space exploration. We must build new probes, new telescopes, new ships that can travel farther and faster. We must push against the boundaries, both known and unknown. Humanity stands at a crossroads. We can choose to be afraid of the darkness, to be content within our small sunlit home, or we can choose to be inspired. We can see the story of Voyager 2 not as a warning, but as an invitation to be bolder, to dream bigger, and to continue the journey that it started so long ago. The stars are calling, and for the sake of our own future, for the very soul of our curious species, we must find a way to answer. The next step is ours to take.